Hello everyone. This lecture is based on vertical and horizontal scaling. Before starting what is vertical and what is horizontal scaling, we would like to understand what is the requirement of scaling the system. Suppose that you have a server, clear, and in that server basically you have written a program, or you can say the code for server. Basically that is what that is a program in which you provide some input, clear, and from that program you want to get some output, and that code is in your server here only. And there is a client can be mobile application or it can be web application. The client send the request to the server. Now it is the task of the server to get the request, clear, and provide that request as input to the code, and the code will provide the output, or you can say the response. That response will be given as response to the client. This is the client and this one is your server. Now suppose that the situation arises like that, the code that was written by a user becomes famous and it is used by many clients. You want to commercialize that and it will be used by many clients. In that case, the many clients will be connected to the server for executing that code. Now, if the capability of your server is not according to the number of requests the server is receiving, in that case, you will not be able to fulfill all the requests from the server which is available with you. Now, there are two things. What we can do in that case? There are two things. Either we extend the capability of the server that is available with me. That means we can extend the hardware's part, the processing power of the server, or you can say RAM, or you can say cache of the machine which is available. Another way can be what? We can purchase more machines and we can just add those machines or interconnect those machines so that they collaboratively work as a server. Now, on the basis of that, basically this adding or increasing the capability of the same server or adding more server, more machines, this is known as scalability. Now this scalability is divided into two parts. One is known as vertical scaling. It means what? You are increasing the capability of the same server by using some hardwares, like you are increasing what processing power of the same server, or you can say the RAM or cache of the same server. What is horizontal scaling? If you are buying more machines and you are adding more machines with your existing machine by the network, by the interconnection among those machines, that is known as horizontal scaling. Now we will look into one by one. First one is vertical scaling. You can see here there is a server, this one, and what we are doing, the vertical scaling is also known as scale up. What we are doing, we are just increasing the RAM, the storage capacity, clear, all these things. We are just upgrading the hardwares that are available in this server, like we are upgrading CPU, RAM, storage of this server only. This is known as vertical scaling. Now, what are the pros and cons of vertical scaling? Pros. First one is simplicity, because it is very simple. The code is running in that server only, and there is no anything required for clustering many devices. Performance, high performance for a single node, because here we will use the IPC, inter-process communication. So the speed, or you can say the performance, will be better in this case. Data consistency, easier to manage because all data is only one system, or you can say one machine, so it is easy. Cons, hard ceiling, it means what? There is a limit to increase the capacity of the hardware, physical capacity of the hardware. Downtime, often we require to shut down the server for some upgrades. At that time, your server will be down. Single point of failure, because there is only one machine. If your machine fails, the entire application will down in that case. Cost, because you are using here the customized hardware, so it will be expensive. Horizontal scaling, it is known as scale out. Clear? It means what? If I have this one server, what I am doing here, clear, I am adding this server that is available with me, clear, with other servers. That means what we are doing, clear, if I have one machine, this is M1, we are adding these M2 and M3 machine with M1 machine, clear, to perform the task, or you can say these will work collaboratively and they are interconnected with some network and that are used to perform the task. In this case, we are not what you can say upgrading the existing hardware. We are just adding more machines, or you can say the node, by using the network. Pros and cons of horizontal scaling. Pros is what? Unlimited scaling. That means what? Basically theoretically limitless, but we can increase the number of machines. We can connect the number of machines in this case. High availability and resilience. It means what? Because the total load is distributed among the nodes. If there is or you can say if one node fails, in that case the other nodes are able to perform the task, so your system stays online always. No or low downtime. System can be scaled up or down on fly without interrupting the service. If you want to add more system, there is no problem. Cost effective long term, because in this case if the number of users in future increase, in that case what you have to do, you can add more machines in the system, so it is cost effective and long term. And we are not using here the specialized hardware also, so it is cost effective. Pros and cons of horizontal scaling. Here we will discuss the cons. Implementation complexity, because the whole architecture become distributed, so we had to use the load balancer to balance the load among the machines that are connected together. And complex application design, it is it provides the complex application design. Data consistency challenge, because you have to manage the data which is distributed among the machines that are available in your system. There is a challenge of data consistency also. Higher initial setup cost, higher upfront investment for infrastructure, configuration and networking setup in this case. Management overhead, because you have to maintain, monitor and upgrade the server. Clear. And that is operationally intensive. Now just take the situation where you will use the vertical scaling and where you will use the horizontal scaling. I think so vertical and horizontal scaling can be used at same time. Let's take an example and we'll discuss about that. Suppose that any person, or you can say anyone, want to set up the system, and he has only one machine at that time, and the number of users are also limited. If the number of users are limited, then from a simple machine, or you can say that from a simple desktop, that person is able to handle the business. That means what? In that machine there is a server, there is a code, and in that code, what you are, how you are, just take an example, then we'll understand that. Okay, suppose that there is a server, there is a client, clear, and this client is basically mobile app in this case, and this mobile app connects with the server by using some API, application programming interface, because the server, the code that is written here in the server, the owner of the code do not want to distribute the code to the clients. Clear? So the client can access this code by using the API only. The client sends the request, and this goes to through the API, and this request, or you can say the code, or clear, is executed here, and the client get the response. Get the response. If the number of clients are less, in that case, it is feasible to run this whole business. Clear? This whole system by using only this machine. As the number of user increases, in that case, what we can do, we can just use the vertical scaling here and increase the hardwares that are available in this machine. So this machine, after some time, this machine becomes a powerful machine. And after that, if the number of user increases, in that case, what I can do, we can just use another powerful machine and connect with this machine. That becomes the horizontal scaling. In this way, another huge machine, or you can say the powerful machine, that can be added with your existing machine. In that case, what happens when the user request or client request goes to any server? Now, inside this, the task is done by using the inter-process communication, and this is a powerful machine, so it will provide the response in less time. But when I'm using this one, when I'm connecting this one machine with this one machine, in that case, we'll use the networking here, and there should be some latency also when I send data from one node to another node, and like that. In that case, there will be latency also. So that means what? Either you select vertical scaling or horizontal scaling. Just look into the situation, and according to the situation, try to design the system by using vertical scaling or horizontal scaling. For example, you know that in vertical scaling there is IPC is used, and in horizontal scaling we are using the network communication. So for network communication it takes more time, but IPC it takes less time. Second point, the consistency is the issue in horizontal scaling, but consistency is not the issue in vertical scaling, because all the things all the data is available in only one system. So my view is what always whenever you want to design any system, just look into the situation, what is the requirement. On the basis of that requirement, select that either you have to use the vertical scaling or horizontal scaling or both. Okay, thank you.